Welcome, and today we are going to be talking about microphones, particularly those that are most commonly used in embedded systems. These include electret condenser microphones, often referred to as ECMs, and MEMS microphones. Many devices that are being built today need to hear for one reason or another, and while there are many different types of microphone technologies, ECM and MEMS microphones are extremely popular in embedded applications due to their small size, low voltage, and low power consumption. So let's jump into what these technologies are, how to use them, and their strengths and drawbacks. MEMS stands for microelectromechanical systems, and MEMS microphones are simply microphones that are created using extremely small mechanical parts, manufactured using the same techniques that are used to make integrated circuits. This MEMS component is then covered with a mechanical diaphragm that creates a capacitor. When sound waves hit the mechanical diaphragm, the sound moves the diaphragm, generating a voltage. In most cases, there's an ASIC or specialized circuit that acts as a preamplifier before sending the signal out to the user. MEMS microphones can be either analog, in which case the output is sent out with no further modification than the amplification. However, they're frequently found with digital outputs, where the analog signal is run through an analog to digital converter, or ADC, and the output is either in pulse density modulation, or PDM, or I2S. PDM connections are nice because there's only a clock and data line, simplifying the connections, but an I2S output can be connected directly to a DSP, which can simplify how many ICs are needed between the microphone and the final output. In either the analog or digital case, the circuitry is fairly straightforward. As you can see on the left, an analog MEMS microphone only needs power, ground, and an output, whereas the digital MEMS microphone needs power and ground and an output, but also a clock and sometimes other control signals. In either configuration, the board space needed is minimal. ECMs, on the other hand, have been an industry standard for years. ECM stands for Electret Condenser Microphone, as they use an electret diaphragm, which is simply a material with a fixed surface charge. Holding a conductive plate close to the diaphragm creates a capacitor, much like with the MEMS microphones. Again, sound pressure hits this diaphragm and a voltage is created. These voltage variations are amplified and buffered with a JFET, as you can see in this diagram. Now, with an ECM, your only option is an analog output, though there are ICs that have been developed specifically to take the analog output and turn it into a digital output, but that is an additional step. As you can see, while ECMs can be as small as MEMS microphones, these are typically larger microphones than the MEMS versions, which do have some benefits, mainly being that they're easier to seal because they're bigger. This means they generally have higher IP ratings. In fact, we offer several ECM models with IP ratings up to IP67. They also require a higher operating voltage than MEMS microphones, so if you're working with something with looser power rails, this can be a better fit. And since they're older, they're an easier drop-in replacement in legacy designs. However, MEMS microphones are smaller and usually less expensive, making them the preferred choice for array applications. Their low analog output impedance and the availability of digital output options make them better in electrically noisy environments, even with their lower voltage and power requirements. They have tight tolerances, can be easily placed using a pick-and-place machine, and can withstand reflow soldering temperatures, another potential cost savings during the manufacturing process. These are the main reasons why MEMS microphones have started to replace ECM technology in newer designs. So, in general, ECMs are better for devices that need protection from the environment, greater flexibility in mounting styles and directionality, designs that have more loosely regulated voltage rails, or for legacy designs that require a drop-in replacement. On the other hand, MEMS are better for smaller, new products where cost is a large driver and space and power is at a premium. Hopefully this helped you understand the difference between these two popular microphone technologies and guides you in the right direction as you're designing your next product. If you have more questions about these microphones or other audio products, check out our audio blogs on our website.